Gymnázium Česká presents the shots of a study of Einstein theory of relativity. We tried to explain some of Einstein's theories on basis of simple experiments and hypothetical situations. Part 1. The time dilation. With increasing velocity of the single system towards another one, even the difference of time flow between these systems increases. Delta t means time perceived by the external observer. Delta t stroke means the time in the system which moves. V is the velocity of the system movement, and c means the velocity of light. We have conducted a series of experiments on the basis of which we try to attest the validity of this theory. Our experimental subject was to run for 600 meters at the speed of 19.1 kilometers per hour. The times were taken both by the stopwatch at the start and finish of the run and by a wristwatch fastened on the runner's hand. The difference of the two times taken with a precision of 1/100th second was 0. To acquire measurable time dilation, we made the subject run theoretically around the whole Earth at the same speed. We implemented the measured times into the Einstein property and found out the time dilation to be 10 nanoseconds. At the velocity closing to the velocity of light, this dilation would get more significant. Again, we made the subject run round the Earth, this time at the speed of 0.999999999999999 times the velocity of light. From the runner's point of view, only 20 seconds have passed, but the observer perceived the time taken by the process rather longer. 50 years. Part 2. The length contraction. With a change of velocity, the subject in one system towards another one shortens in the direction of velocity's vector. L means the length of the subject in the system of the external observer. L0 means the length of the subject in the system which is moving. V again means the velocity of the system which is on the move, and c means the velocity of light. We decided to simulate this phenomenon using our experimental subjects. Here you will see that the subject, the runner, who is now considerably higher than the time taker, the observer, will lose height when moving extremely swiftly. This situation, however, does not correspond with reality for several reasons. First, the length contraction comes to pass only in movement, so after stopping, the subject would return to its normal size. Second, the contraction happens only in the direction of the velocity vector, so in this case, only the width of the subject and not its length would be changed. Part 3. The energy of matter. According to Einstein's property E equals mc squared, all matter comprises a vast amount of energy. Today it is, however, impossible to extract the energy by any standard means. Even by shattering complex atoms, followed by a nuclear reaction, we gain only about 11% of usable energy. There is, however, a theoretical mean of gaining all the energy of any material. That is the interaction of matter with antimatter. Antimatter is the counterpart of matter. Their mutual contact inevitably leads to an annihilating reaction, as a result of which an unimaginable amount of energy is unleashed. The effect of this interaction would probably look like this. Mass destruction is wrought. By the way, in vacuum sound is unable to spread, so this explosion would not be audible.